Where exactly is the James Webb Telescope right now? Unlike the Hubble, which orbits just a few hundred kilometers above Earth, Webb is stationed an unimaginable 1.5 million kilometers away. But why so far? And what secrets has it already uncovered? Stay with me, because what you're about to learn might just change how you see the universe forever. When we look up at the night sky, most of us think of twinkling stars, distant galaxies, and the vast unknown beyond. But hidden in that darkness, orbiting far beyond Earth's reach, is one of humanity's greatest achievements, the James Webb Space Telescope. It's more than just a machine. It's a time machine, a cosmic archaeologist, a dream catcher for our biggest questions about existence. Today, we're going to uncover not just where it is, but why it's there, how it got there, and what it has already revealed to us. Before we dive into its location, we need to understand what the James Webb Space Telescope truly is. Often called the successor to Hubble, the JWST isn't just an upgrade, it's a revolution. Launched on December 25, 2021, after decades of planning, delays, and intense engineering challenges, it represents the pinnacle of human curiosity. Its mirror, made of ultra-lightweight beryllium and coated in a microscopic layer of gold, stretches 6.5 meters across, about 2.5 times larger than Hubble's. This massive mirror allows Webb to collect far more light, peering deeper into the universe than any previous telescope. But it's not just the size that matters. James Webb was specifically designed to see in the infrared spectrum, the kind of light that can travel through cosmic dust, the kind of light emitted by the oldest and most distant objects in the universe. If Hubble showed us galaxies like beautiful portraits, Webb shows us the unseen stories behind them. The journey to create the James Webb Space Telescope is almost as epic as the telescope itself. Planning began in the mid-1990s, right when Hubble's images were transforming our understanding of space. More than 10,000 people from 14 countries contributed to the project, led primarily by NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. It took nearly 30 years and over $8 billion to complete, and it wasn't easy. The telescope had to be built to survive a month-long journey into space, deploy a delicate 5-layer sun shield mid-flight, unfold its mirror petals, and calibrate its instruments perfectly, all without human hands touching it again. Every step of its construction involved engineering miracles and countless tests, because if anything went wrong after launch, there would be no way to fix it. The mission of the James Webb Space Telescope is breathtaking in its ambition. Peer back in time to observe the very first galaxies that formed after the Big Bang. Study the formation of stars and planetary systems. Analyze the atmospheres of exoplanets to look for signs of habitability or even life. Expand our understanding of dark matter and dark energy. In a sense, Webb is our ultimate explorer, not just peering across space, but across time itself. Unlike the Hubble Space Telescope, which orbits Earth at a relatively close distance of about 570 kilometers above the surface, the James Webb Space Telescope ventures far beyond. It is stationed approximately 1.5 million kilometers from Earth at a unique and strategically important location known as Lagrange Point 2, or L2. Lagrange Point 2 is a fascinating concept in orbital mechanics. It's a gravitationally stable region where the gravitational forces of the Earth and the Sun, combined with the orbital motion of a satellite, create a delicate balance. This balance allows an object like the James Webb Telescope to essentially hover relative to Earth as both move around the Sun. This stable placement is crucial for maintaining a fixed orientation and minimizing fuel consumption for orbital adjustments, making it an ideal home for a long-term space observatory. Positioned at L2, Webb enjoys a continuous, unobstructed view of the cosmos, free from the glare and infrared emissions of Earth. This uninterrupted gaze is essential for capturing faint signals from the distant universe, signals that would be easily drowned out if Webb were placed closer to our planet. Additionally, the location enables efficient communication with mission control, allowing the telescope to send massive amounts of data back to Earth with minimal delay. Another critical advantage of Webb's distant stationing is temperature control. The telescope's instruments must be kept extremely cold to detect the faint infrared light emitted by the earliest galaxies and distant exoplanets. To achieve this, Webb is equipped with a 5-layer, tennis court-sized sun shield that blocks heat and light from the sun, Earth, and Moon. Thanks to this sun shield, Webb maintains a chilling operational temperature of about -233 degrees Celsius, approximately -388 degrees Fahrenheit. Without such frigid conditions, the sensitive detectors on board would be overwhelmed by their own heat, making it impossible to observe the faint, ancient light from the farthest corners of the cosmos. In essence, Webb's location at L2, combined with its innovative engineering, enables it to peer deeper into space and further back in time than any previous observatory, opening a window into the mysteries of the universe that have remained hidden until now. In just 3 years of operation, JWST has completely reshaped our view of the cosmos, unveiling details of the universe that were once hidden from even our most powerful instruments. One of its most celebrated achievements is the discovery of over 60 new exoplanets, planets orbiting stars beyond our solar system. Some of these exoplanets show intriguing atmospheric signatures, such as the presence of water vapor, carbon dioxide, and even potential hints of other complex molecules. These findings open tantalizing questions about the possibility of life elsewhere in the universe and help refine our understanding of planetary formation and habitability. The telescope has also provided stunning images of stellar nurseries, vast clouds of gas and dust where new stars are being born. These regions, such as the iconic Carina Nebula, are captured in unprecedented detail, revealing the delicate structures and dynamic processes that give birth to stars and planetary systems like our own. For the first time, scientists are able to witness the earliest stages of stellar evolution with remarkable clarity. Perhaps even more astonishing are the first glimpses of ancient galaxies. James Webb has photographed galaxies that formed just a few 100 million years after the Big Bang, offering a direct window into the infancy of the universe. These ancient structures challenge existing models of how galaxies evolved and provide critical data for understanding the timeline of cosmic history. Webb's sensitive infrared instruments have also allowed it to peer through dense cosmic dust and capture extraordinary images of black holes and supernova explosions. By studying the environments around these cosmic giants, astronomers are learning more about the life cycles of stars and the forces that shape galaxies. In addition, JWST has been able to detect chemical fingerprints in the atmospheres of distant exoplanets. By analyzing the spectra of light passing through these atmospheres, scientists can identify the presence of essential molecules like water, methane, and carbon dioxide. This technique brings us closer than ever before to finding planets that could support life. Each new image, each new data set, is like turning a page in the universe's oldest history book. Every discovery made by James Webb not only deepens our understanding of the cosmos, but also reminds us how much there still is to explore. And with its journey only just beginning, the James Webb Space Telescope promises to keep revealing the secrets of the vast unknown for years to come. Even though the James Webb Space Telescope is often called the replacement for Hubble, that's not entirely true. Hubble is still very much alive, orbiting Earth and providing invaluable data. The two telescopes complement each other beautifully. Hubble observes in visible and ultraviolet light, while Webb excels in the infrared. Together, they offer a fuller, richer picture of the universe than either could alone. It's a reminder that in exploration, old eyes and new eyes can work together to unlock the mysteries of existence. The James Webb Space Telescope is more than just a scientific tool. It's a beacon of human hope, curiosity, and the endless drive to understand who we are and where we come from. By peering deeper and farther into the universe than ever before, Webb isn't just exploring the cosmos. It's helping us explore ourselves. And the most exciting part? This journey has only just begun. If the James Webb Telescope can look back 13 billion years into the past, what might it find next? Could it discover the first real evidence of alien life? Stay tuned, because in our next video, we'll dive into what Webb's latest observations might reveal about worlds beyond our imagination. Make sure to subscribe and join us as we continue to venture into the vast unknown.